Okay, I'm really not sure. I'm able to hear it. Okay, let's. Maybe I'll share this code with you. Maybe I think once you can run it in a MATLAB and see, you can hear a beep sound. You can hear a beep sound corresponding to the frequency 440 hertz. Okay, the 440 hertz the beep sound will be, or when you see this recording of this video, what I will share, you can hear the beep sound there. So try listening to that. It will be very good to see. If I change the frequency accordingly, you can see that the sound intensity or the quality of sound is also going to change. Okay, so that is one thing I want to say here. Now, next one, I am going to create a noise signal. So, what is a noise signal? Okay, I am going to create a noise signal, and I am going to visualize a noise signal. We in communications, we always say, right, we have noise everywhere. It is a additive white Gaussian noise, but we are not sure how a noise signal will look like. Okay, so here I'm going to create a random white noise. So see here, I have taken the sampling frequency 16,000 hertz. Accordingly, I'm fixing my time, and I'm using the function rand_n. Rand_m generates a Gaussian random variable. What is the size of my noise? It is the same size as of the time, because I'm going to use the plot function to plot the noise and time versus noise. Now, once I generate the white noise, I am plotting it. Plot TTF. This plot TTF command is an inbuilt command where you can give the y comma x. It is a user-defined function which is given by MATLAB. So plot TTF will give white noise comma time, and time is going to be 1 by fs. So I'm giving white noise comma 1 by fs. Now it is going to be my white noise. And you know why the name white noise is given? Because white consists of all the colors, right? So white noise means it will have all the components of all the frequencies inside it. That's why it is called as a white noise. Okay, but if I want to filter a particular frequency from that white noise, that is possible. So see here, I'm going to use an FIR filter. The order of the filter is 48, and I'm going to filter only this portion of my frequency. So 1200 to 1800, that particular frequency is going to be filtered. Okay, that is going to be filtered. And I'm going to see after filtering, I'm going to call it as a white pink noise because I have filtered something. Okay, so it is a pink noise. I'm going to use the filter command. I'm going to pass the filter coefficient H, and I'm going to pass the signal white noise. The filter takes input and coefficients. So coefficient is given by the H, and the signal is given by white noise. So after filtering, the sequence is stored in pink noise, and I am again plotting the pink noise. Okay, so this is what is the objective now. So I'll run this section. Just a second, some issue with the